Ask a few friends what their most desired superpower might be, and you'll almost certainly run into this answer: teleportation.
Ready to beam up, Jim?
Energizing.
Few concepts from science fiction have captured the imagination quite like the ability to beam yourself to any place at any time in an instant, perhaps now more than ever before. But unlike many of the fantastic powers that grace the pages and realms of science fiction, teleportation is real.
Scotty, beam me up.
In fact, people all over the world are using teleportation right now. Only it might not be what you think. Teleportation is possible thanks to a phenomenon called quantum entanglement. Particles such as photons can be prepared in pairs so intimately linked that measuring the state of one particle automatically determines the state of the other. When one is observed to be spin up, the other will always be spin down, and vice versa, regardless of how far apart they might be. Like quantum soulmates, these particles could be separated by inches or by light years, and still they'd share this special bond. Some might call that romantic. Einstein called it spooky action at a distance. And he's not wrong. Teleportation is a spooky prospect. History is littered with strange tales of people and objects disappearing into thin air, only to reappear somewhere completely different. Take the infamous tale of the Philadelphia experiment, for example. In the twilight of World War II, so the story goes, the naval crew aboard the USS Eldridge had outfitted the destroyer with a bevy of top-secret generators. Their mission was to generate a force field strong enough to teleport the USS Eldridge from its home in the Philadelphia Naval Shipyard to the Norfolk Naval Shipyard in Virginia. According to the event's only supposed witness, the mission was a success, sort of. The ship reached its destination almost as quickly as it had disappeared, but its trans-dimensional journey had left some crew members fused to the ship's hull. Though widely discredited as a hoax, the Philadelphia experiment captured the public's enduring fascination with teleportation. Fortunately, bona fide proof of teleportation would come from real experiments before the turn of the century.
In our lifetime, what's more likely, teleportation or time travel?
We've already done teleportation. Done it, so single particles.
In the 1990s, researchers had discovered how to harness Einstein's spooky action to teleport photons across a room. Well, not exactly. Quantum mechanics unfortunately forbids the teleportation of matter. It's quantum information that's fluid. This information refers to the physical description of a particle's quantum state. By transmitting that information from photon A to photon B, researchers could actually transform photon B into photon A, a long-distance imprinting of sorts. Since then, researchers have gradually upped the ante, teleporting quantum information between particles across labs, across cities, and even in orbit. And along the way, quantum teleportation has found its way into high-end cybersecurity. The ability to shuttle information between entangled particles, it turns out, could offer the strongest lock-and-key mechanism for exchanging secure information. After all, you can't tap a wire if there's no wire to tap. So when can we expect teleportation to scale up from the quantum to the quotidian? It could be a while, because quantum mechanics allows only for the teleportation of information. Instant transport, as conceived in popular culture, will likely never be possible. And so far, researchers have been unable to teleport information about anything larger than a few atoms. But consider this. Let's say researchers ultimately discovered how to teleport information about humans from one place to another. Your entire being could somehow be transported to a U-sized bundle of atoms, far, far away. Would that teleport really be you? How's that for some spooky action?
Gentlemen, beam me aboard.